Unit 10, Day 3. This is Mr. McGough up in R12, and I'm going to go over our Day 3 notes. First, some special products of polynomials. So when we do our multiplication of polynomials, we're going to do it using a method called foiling or double distribution. So first we're going to take our first term of our first portion here, our first variable in our first term. We're going to multiply it times each of the terms in the second part. So a times a is a squared. A times negative b is negative ab. Now we're going to take our plus b and multiply that times each part of the second term. So b times a is ba, or ab. The order doesn't matter. So I'm going to write it the same way as I wrote my minus ab. This time, though, it's plus. And then positive b times negative b. A positive times a negative is negative. And b times itself is b squared. So here we see we have a negative ab and a positive ab. They cancel each other out. So our product is a squared minus b squared. Our second special product. Well, I'm going to write this out. Squaring something means to multiply it by itself. And then I'm going to use the same process. So first, I'm going to take a and multiply it by a squared. A times b is ab. B times A is BA, or I can rewrite it again as AB. And B times B is B squared. Here my middle terms are the same. I have one AB plus another one AB. So I combine those like terms. And my solution becomes A squared plus 2AB plus b squared. A minus b squared, well, that is a minus b times itself, a minus b. So again, I'm going to take a, multiply it by a, that's a squared. A times negative b is negative ab. Negative b times a is negative ba, or I can get the order negative ab. Then negative b times negative b. A negative times a negative is positive, and b times b is b squared. So again, I see like terms in the middle. I have negative 1ab and another negative 1ab. So I'll combine those like terms, and I get a squared minus 2ab plus b squared. Let's go ahead and apply this to some sample problems. So on number 1, 2x times 2x. Well, 2 times 2 is 4, and x times x is x squared. 2x times negative 3, negative 6x. 2x now has been multiplied by each, so I'm going to move on to the 3. 3 times 2x is 6x. 3 times negative 3 is negative 9. My middle terms cancel each other out, and I get 4x squared minus 9. Now, if I'd recognize this as my very first special product, a plus b times a minus b, I could have just rewritten it as 2x squared minus 3 squared, which would again give me 2x times 2x is 4x squared minus 3 times 3 is 9. Problem number 2. To start out, I really encourage you to write it out. Squaring means multiplying it times itself. and using your double distribution. So here, 2x times 2x is 4x. 2x times positive 3 is plus 6x. Now I'm done with my 2x term. Moving on to my 3 term. Positive 3 times 2x is plus 6x again. Positive 3 times positive 3 is positive 9. I'll combine, oops, I forgot my square. I'll combine my middle terms. So I have 4x squared plus 12x plus 9. Looking back at my special rule, I see a was 2x. 2x times 2x is 4x squared. 2 times a times b. A was 2x, b was 3. So 2 times 2x is 4x times 3 is 12x. Plus b squared, 3 times 3 is 9. Problem number 3. Again, I'll write it out and multiply it out. 2x times 2x, 4x squared. 2x times negative 3, negative 6x. Done with my 2x term. Now negative 3 times 2x, negative 6x. Negative 3 times negative 3. Negative times a negative is positive. 3 times 3 is 9. Combine my middle terms. 4x squared minus 12x plus 9. Looking back at my form above that, a squared, 2x times 2x, 4x squared, minus 2ab, 2 times 2x is 4x, times 3 is 12x, so it's minus 12x, plus b squared. 3 times 3 is 9. Now you go ahead and try A, B, and C. Pause your video, try them out, and then I'll show you the answers. Okay, hopefully you tried those. On A, I have 9x squared plus 15x plus 15x plus 25, which yields 9x squared plus 30x plus 25. On letter B, I have y squared minus 6y minus 6y plus 36, so it becomes y squared minus 12y plus 36. On letter D, I have 16a squared plus 4a minus 4a minus 1. Those two terms cancel each other out, so I have 16a squared minus 1. Problem number 4. Now I have x terms and y terms, two variables. Well, my process remains the same though. 2x times 2x is 4x squared. 2x times y. Well, I can't really multiply x times y because I don't know what they are. So instead, I list all three terms, the 2, the x, and the y, as all being multiplied together. Now I'm going to go negative y times 2x. Well, the order I'll switch around. I'll make it minus 2xy. Negative y times positive y is minus y squared. Now I have a 2xy and a negative 2xy. Those are like terms. I'll add them together and they eliminate one another. So now I have 4x squared minus 1y squared. Go ahead and pause again. Try letters D and E on your own. Hopefully you've tried those now. Welcome back. We're going to go m plus 3n squared, so it times itself. So I have m times m squared, m times 3n plus 3m n, 3n plus n plus another 3m n, and then 3n times 3n. 3 times 3 is 9. N times n is n squared. I'll combine like terms in the middle, so plus 3n makes plus 6n. So m squared plus 6mn plus 9n n squared. My last problem. Well, this doesn't look the same, does it? Because I have 3a and I have 2a. That's not the same term. I have negative 2b and positive 3b. Those aren't the same term either. Our coefficients are different. So let's just go ahead and multiply these together by distributing. 3a times 2a is 6a squared. 3a times 3b. 3 times 3 is 9. A times b is ab. Switch pen color to do the second half. Negative 2b times positive 2a becomes minus 4ab. Negative 2b times plus 3b becomes negative 6b squared. Now, I do notice I have like terms, but they don't eliminate one another. They certainly don't double, but I have 9 of them, 9ab, minus 4 of them, 4ab. So 9 of them minus 4 of them is 5. ab as my middle term. So I have 6a squared plus 5ab minus 6b squared. Now a word problem. A square swimming pool that has sides that are 20 feet long. It has a walking path, x feet wide, that goes around the entire edge of the pool. We're going to write an algebraic expression that represents the total area of the pool and the walking path. Well, first off, if I know it's x on all sides, I can draw out a picture. And what do I see as the width? Well, first off, area equals length times width for a square and for any rectangle. For a square, in particular, the length and the width are the same. Sometimes we just call that the length of the side times the length of the side, or side squared. Hence why we call it a square, or hence why we call this squaring a number. So what is the length of a side of the entire area including the walking path? Well, if we go from top to bottom, it's x plus 20 plus x again. So 20 plus 2x. If we went the other way, it would also be x plus 20 plus x again. Another 20 plus 2x. Or 20 plus 2x squared. Now we're going to use our distribution to calculate. Well, I could have done this as 2x plus 20. Probably would have been better to do it that way. 2x plus 20 times 2x plus 20. We'll do our first terms first. 2x times 2x is 4x squared. 2x times 20 is 40x. 20 times 2x is 40x. Sorry, I should have drawn all of my arcs. And then 20 times 20 is 400. So my equation becomes 4x squared plus 40x, and 40x more is 80x plus 400. And that's my area in square feet.